No?
Okay, sir. Great.
Yeah, there is no issue. You can, if you don't mind it, you can present, and I can tell you that so that others will also know that how will submit. Actually, I will open, then it will show instructor side. So that is, I want to show with the student side so that all of you know it.
Sure, sir. Could you please wait for 2 minutes?
Yeah, yeah, no issue. So let's in between, let's discuss other thing. Once you will be okay, then you can. Okay. So in week three, the topics we have already seen, and now let me present. So I hope anyone have not any. So at least to have solved some problem, you know that. So I want today to discuss with examples what is a linear independent dependent span member sync. Yeah, my span is we have spent it lots of time. Spanning set I and this basis. Let's discuss this basis also. This is yesterday I did not discuss the basis. The same meaning is there as you studied in week one. But let's discuss in R3. So, for example, let's say I have so this is June 26.
Shall I share it, sir?
Yeah, 1 minute. Let me
Okay.
stop it. Okay, so this is how it is. The interface you will see each time. You can just cut it this, just cross it, or you just move to some other place. Yeah. Okay, so you have to click for the maths to this term 225. Just click on there. So okay, you are already clear. Click there. Okay. Yeah. So in the class, what is the process? You have to open your classroom, or the simply just open the graded assignment, or just open this portal. Front end portal. If you open week three portal, let's do from starting. So just open this 3-9 graded something is there, right? Not the leftmost tab, the corner. No, 3.9 in the your it's showing. No, not there
Sorry, sir.
in this center. Yes, that side. Corner in the tab only. I'm saying the window. Sorry, in the window, the corner,
This one.
leftmost, the right side of the calendar. If you just
Okay,
open
okay.
your portal, just open your portal where you will see the graded questions. I just asking, just where you will see the graded question.
In portal, sir.
So open that portal. Yeah, that is what I mean to say. Yeah, so this is your portal, and this is the graded assignment. So click here to submit. Once you click the submit, it will reflect to this. Yeah, I think here. Yes, it will reflect to here only. And now this click on this ITM posted new week the new assignment week 3. Yeah, just click on that. Yeah, just click on that. Yes, that's all. Here it is, and you can see the graded assignment questions. Okay, you can see there it's
Yes,
showing
sir.
to the week 3 GA. Okay, and what now? What you will do? Have written your handwritten answers? Okay, now the work is that you rightmost corner you can see your work. Add to create, you can add to create. Just click on to add to create. Yes, So it will show you to upload, from file. So file only if you doing in your copying. So if you click on this, this will show the attach the file.
Shall I click it
Yeah,
on
you can.
click on it?
So if you just do that, click on file. So it will reflect to your computer, local computer. Just browse it. Any PDF you find, just browse it. Okay, and now if you choose any PDF which you have given, not any PDF means whatever you have wrote, you have given in the computer. Okay, and now you just click and open that. So or maybe select. No, there is option will give select. Once you upload there, okay, either you can just go ahead. Okay, just add to create. Just do that. Add to create. Okay, file the below the file one. Okay, and then browse. Just browse that. Select the any whatever you are, just please select the PDF, any of the PDF. Yes, so it will upload. Let's do that. Okay, once it will be uploaded, so okay, it's upload now. Finally, don't, I will suggest you don't turn in. Okay, so it's saying that don't turn in, so don't do turn in, but you have to finally, whenever you are submitting after uploading, you have to do turn in. Don't forget. Okay, always. So you just click on got it. No, don't do the turn in, just click on got it. Okay, so if you want to okay, Sonali, don't do turning. Okay, I'm just telling that. So whenever you will do the final submission after upload, you have to do turning. Okay, just if you click the turn in, your submission is done. So don't do here is. Now if you want to remove, you want to, you just delete that. Yes, you can delete that. Yes, if you did it, now it is not saying. So whenever you want to submit, just add or create, and then finally you have to upload there, and necessarily you have to do turning. The final submission you have to do after uploading that. Anywhere you know that after uploading you have to do final submission. So here the final submission name is turning. Okay, this is how you will upload.
Okay, sir. Thank you, sir.
Okay,
Shall I stop my
so
sharing?
you can stop. Yeah, you can stop saying.
Okay, sir. Thank you, sir.
Okay, so I hope all of you got who is here at least now, who will see the live session. Get will get it also. Okay, so let me present my screen now. So so let's do the basis, the important thing. So suppose I have a vector space. Okay, let me, let's say I have a vector space R4. Okay, I have a vector space R4, and I have a subspace yes of this kind, uh, x y z, maybe. So it is R4, no? So R4 means it will, the four coordinates should be there, x y z and w. Okay, and 0 and y plus z plus w. So y plus w is equal to 0. Okay. So this is a subspace. So this is actually represent a subspace. I just randomly choose as a subspace. Okay. So the question is, I want to find a basis of it. This is a subspace of R4. I want to find the basis, also the dimension. These two questions are there. Okay, the subspace S is of which is a subset. You know already. It's clearly you are able to see this is a subset. Yeah, but it follows the operation as in R4, means you can add vectors last time yesterday we have seen adding the vector. What is a vector space? I clearly told you that what is a vector and how you will add, okay, how you can multiply, add by a real number which is called a scalar. Those things I've clearly seen yesterday. Spent lots of time on there. Okay, and now we have seen the some subspaces also. So I have this kind of subspace of R4. I want to find the basis of it. So the question is how we will find the basis of this vector. At least basis, find a basis. No, there would be a basis because for a subspace there are a lot more, okay, infinitely many bases. Okay. Basis means I want to find those vector which generate this. Yes, mean to say I want to find some vectors, okay, which actually whatever the vectors you will get here, all vectors can be generated by just do the span of it. If you do this span of this, you can exactly get this subspace. So it's written in this fashion, a subspace generally the set form also this one. But I want to find a different type of in different way. That means I want to find such vector which actually do the linear combination. Span is last study we have seen that what is a span. So I just do the span. I will get the whole this subspace. So the question is how I will find this vector v1, this vector v2. I don't know how many vector would be even. I don't know how many vectors needed to span. Maybe three, maybe four, or maybe one only would be sufficient. I don't know how many. So first I have to confirm that how many vectors is also needed to span this whole. Okay. So this will how many vectors at least needed. So this will tell you. So this will give the basis element also means these vectors are actually called the basis element. Okay. So that this is what the basis. Basis is a collection of vector which span the space, which span the space. This is what? This is a collection of vectors. If you do the span, it will generate the whole subspace. That is what yours this basis is. The question is why this is important, why we want this such basis. The question is that the reason is that all of you know from all of your maths backgrounds know that the set comprehension word. Okay. So previously, whenever you know the natural number, no, this is a natural number representation. Capital N with the left side is two vertical bar, and so one could be written as like this. N is written like this. This is a set of natural number. But if I'm representing like this, 1, 2, 3, 4, dot dot dot, this is also tells you the set of natural number. But this representation is not so unique, or maybe no, not that much feasible to always use it multiple time. We want this, we generated, or we ourselves we said that okay, this is the representation of set of our natural numbers. Okay. So similarly, this is a subspace, no? So I want to find much simplified representation. This is one answer for this. We are actually finding the basis, and also this will give the idea that no. So suppose in the real life problem, uh, somebody is asked your family. Uh, Suppose somebody is asked your the new person came, okay, and started asking your introduction, okay, the home introduction, the your family, the all around the family introduction. He knows your father, okay. He knows your father, but by random or by chance, he met you and started asking about your family. So, in place of telling you your brother, sister, mother, or other things, okay, these types of the introducing these all. If you just say your father name, he will understand, okay, this is the family. This is what it is. So in place of saying this all, this is what this is, we just say, okay, this is the basis, means these are the vectors only. And you'll just say the basis of this subspace is this one. So it will be understood that okay, we are talking about this subspace. That's all it is. The meaning is the same. Basis is a very important, crucial thing that if you just tell about that, the person will understand. Okay, you are talking about this subspace. As you know, in place of saying your family member name, if you just tell about your father name, he will understood that okay, that person's family or you are belong to that family. That's all it is. So this is the meaning of it, the basis. Okay, so clear is it? What is a views of basis in the real life problem? It is when connected with the real life. Not
Yes,
so.
sir.
This is one use to saying this is a or why we want this basis. Okay. So, but in place of saying this, so there are a lot more uses, not only this one. You will see later slowly, but I just given one use of that why we want basis. Okay. So before to start that, now next is dimension word. So if I will interlink with the the same example, not only you and your brother, okay, the cousin brother is there, and the new person also came here, okay, and he just told that okay, who is that person, okay, then you just introduce that okay, this the family, this brother sister, these all there. In place of that, if you just tell your uncle name, that would be suffices to know that the whole family, even in your from background, even that okay, your grandfather is that one, he will know that all. So this is how it is. So means here that how many element in that, how many root element here. So in how many element in the basis is called dimension. Same way is here. So he will, as like he will understand, okay, in your grandfather, he knows that how many sons are there in in your grandfather, but not aware of that as you met him. So he will understood that okay, this is the root of this many persons or this many fathers of father, uncle, and elder father, whatever the things you will say. Okay. So I mean to say the number of element in the basis. Like here, if suppose this is generated by only these three vectors, okay. Let's say till v3. I don't know. I don't want. Not I don't want. Only generated by these three elements. So dimension is going to be of this subspaces. So this is the only dimension tells you how many vector in the basis. Okay. So let's start finding the basis here. So I want to find the basis of this subspace. So what we will do here, we'll take these equations. Okay, let's take these two equations is equal to 0 and y plus w is equal to 0. Okay, I just take these two equations. If it is one equation, this is easy to know. If it's two equation, let's take these two equation. And now using these equations, let's solve. Let's solve this system of linear equation. So many types now. This is a system of linear equation. Hope you many times know how to solve now this, because now you are in maths 2 and you have seen this in maths 1. So and this is a week 3, so all of you aware of it that how we'll solve this. This is a simple numeric thing. And yeah, this is a 4 variable. So even if you want to represent in the more broader way, so that means x plus y plus z plus 0 time w is equal to 0, 0 time x plus 0 time y plus no, not 0 time y plus 0 times z plus w is equal to 0. So all four variables are visible now. So either you can do this in the matrix format now, 1, 1, 1, 0. Okay. And the augmented matrix, augmented matrix is now you can right side, you can write like 0 here, 0, okay, 1, 0, 0, and 0. So this is already in, whatever you want to do, this is already in the elimination form. So there is no use of it. You can now easily solve this. So there is no forming in the matrix form. There is no use of forming in the matrix form. What you can do, so you can just write y is equal to, you can take the second equation, you can write y is equal to minus w. And you can substitute in the first equation, you will get here x. In place of y, you can substitute minus w and plus z is equal to 0. So finally you can write x is equal to w minus z. So by this way you can get that, okay, how many free variables. So you have x is equal to minus, finally you have x is equal to w minus z, y is equal to minus w. Okay. So, and this tells you that you have free variable w and z. This tells you that you have free variable w and z. You can assume w is equal to some c and z is equal to some c prime. So by this way, you can finally, you will get the solution here, x is equal to c minus c prime, y is equal to just c minus, minus c, w is equal to, you have already assumed c, and z is equal to minus, c prime. So finally, if you write a solution, okay, so what you will get here, if you write that, so if you write x, y, z, and w in a vector form, so you will write like this which is nothing but c minus c prime minus c, c and c prime. This is what it is, right? So if you want to write in the more comprehensive form, so you can write c, and you can write like this. So c, which is, I am now separating c and c prime. So which is here c. So you can write 1, minus 1, 1 and 0 plus c prime time minus 1, correct? And 0, 0 and 1 is here. So to see it, if you add these two and after multiplying, you'll exactly get this one. This is what I slowly wrote this. Why I am writing, you will see the reason actually. Why I am writing, you will see the reason. I will tell you the another way also, but why I am writing, this is the reason only. Actually, this now if you see, this is a vector, so this is a vector, right? This is a vector and this is a vector. And if you check that, this vector is actually satisfy this equation, and this vector also satisfy this equation. And all solutions are actually can be generated by this, is right, because your x, y, z here is in this fashion only. This tells you the linear combination, c and c prime your real number. So your solutions are actually linear combination of these two vectors, and that is what we want. So actually your whole vector space is generated by only these two vectors. This is what I mean to say. So means here the basis of this is just 1 minus 1, 1, 0, and means your basis elements are this one only. That's all. These two are your basis element. That means dimension of this subspaces, there are two elements are there only in the basis, so dimension is 2. This is one way to solve or to get basis element. You assumed here c and w is c and c prime. Okay. The another way is, in place of assuming, once you got that, okay, w and z are free variable, so what you usually do, you will assume w is equal to 1, okay, and z is equal to 0, and using this way you will get a vector. So vector would be now what, x is equal to 1, Okay, y is equal to -1. See, the same vector actually you will get here, and w is 1 here and 0. And okay, and now if you assume the second way is, now you will assume w is equal to 0 and z is equal to 1, then you will get here -1, 0, 0 and 1. See that the same vector here you will get. The same vectors are here. So either in place of assuming C and C prime, if you start doing like this, you have seen in the lecture many times to find the solution. So this is how it is. So you will get two vectors. So this is your basis, a basis vector, and so the dimension is 2. So same answer you will get here. So this is one vector. You can assume any. You can assume first w is. You can assume w is equal to 2 and z is equal to -1. It means you have to choose like a very separate thing so that it will not interconnect. Okay. Then using that you will get a vector that is also form a basis element. So this is how you will get that basis of a subspace when your subspace is given in the equation form. Okay. I don't know, is it clear to all of you? Is it clear?
Yes, sir.
Okay. And I hope all of you get that was the basis. So if you see the examples here, no examples, professor is actually solving many times system of linear equation. Actually, and the meaning of it is the same. Means how we'll get the basis or how will, what does that mean? So when it. Span and dimension in 3 cross 3. The same is there. So first he is telling me how you will solve the system of linear equation. Okay, if you have this kind of, either you can form the linear equation, sorry, matrix, and you can take the span of it. But I want to eliminate, so you can do the elimination. So he has done the elimination, and the process is, see that the elimination process is whatever we have discussed yesterday. The same thing is there. See how he solved. He assumed also. Let's say u is there, so he separated u like this, and now start doing this. So same thing is there. If you watch the lectures also, it will give the idea how it is. We have solved this in 4 variable case. You can start doing that. Okay. So this is a, we have discussed one of the good example, and all other are here the same. This is also an example to solve. If you have 3 4 4 3 case, have 4 variables as here this one.
Sir, in the 3 by 3 case, we can also
Hmm.
convert the matrix into the row reduced echelon form, right? And then
Yes,
if we
yes.
find that something is linearly dependent, then we will just reduce the dimension by 1.
Die one. That is what we are doing elimination. That is what why we are transforming the matrix format to understand which one is depend on the other. Let's remove that. Get the actual vectors and say them. That is a basis. That many element is there in the basis. So that is your dimension.
Okay, sir. So it is not actually compulsory to convert it into these linear equations. We can literally just solve it in the matrix itself.
Hmm. Yes. Okay. So at least all of you know what is a basis. Yeah. That this is good that you are doing that. And yeah, at least know what is the basis. So I have just given a real life example what is the basis. So basis is why this is important. See, whenever you are understanding a linear algebra, always you will see the basis. Basis means base. You want you want to find the root vectors which actually generate. So actually all vectors are actually kind of root vectors. Okay, I will do one more problem. I will do one more problem with you with yours. Means you will I will ask you to solve and then we'll start doing that. You will solve with me only. All of you will solve with me. Okay. We'll try to do in R5 here. And let's move on to more higher dimension. So basis is root to know that okay, like span or I mean to say if you have a subspace, if you write all span of all in whatever how many vectors are generally a space have subspace have infinitely vector. You can take 4 vector, 5 vectors, 6 vector, how many vectors you want you can take and the span. And you'll get the same sub means you can get the subspace, the same subspace. But maybe that subspace can be generated by only 2. So how will get that which two are important there? So the elimination process is important to get it okay, only these two vectors are important. And actually these two vectors also called basis for that. Basis element means the root vectors are those vectors called root vectors. So let's do one more problem in the more higher dimension. Let's do on R5. Okay. So that you will not fear with when the dimension is increasing. Okay. R5, R6, any dimension you can go. There is no issue. Means the problem will be asking if you understand only R2 and if it is going beyond of ADN is there, you can easily do. There's no issue. So let me write another example. Okay, so let's say I have a subspace. Yes. Again, if it is R5, yes is a subset of R5. That means 5 coordinate would be there. X, Y, Z, U, and let's say W. See that? Have 5 coordinates now. Okay, have 5 coordinates now. This subspace. Okay. Now in this coordinate there is a relation. Okay, saying to be the subspace, yeah, that's fine. Actually this is a subset, but what are the element in that? So the element are is such kind of that coordinate have such a relation. So let's say x plus y plus z is equal to 2, not 2, actually 0, and y plus u is equal to 0, x plus w is equal to 0. So these are the relation in the within the coordinates. Okay. So I want to find the basis of this subspace. So all of you try this and can tell me that all of you understood the basis thing. So all of you try this first problem. I want to find the basis and dimension. These two things I want to find. So all of you try this and let me know what is the basis of it. I'm just giving some times to all of you to solve it. Okay, I'm muting myself. I'm all of you try this. The same process. Just follow either this one or this one. Whatever you want to follow, you can follow that. And let me know the vectors. That how many vectors needed to span this subspace means basis vector. So all of you try this. I'm muting myself, and I'm giving time to you to solve it.
Excuse me, sir.
Okay, so anyone have solved it? Here we have 5 rows. No, it have only 3 rows, but 5 columns. Actually, whatever professor is solving, he is solving the way to solve a system of linear equation. Mostly is solving the system of linear equation to get that how you solve. Okay, is solving the system of linear equation with 3 variable, 4 variables, and that is what it is only. But the anyhow the right side here, the constant, some numbers are there. But in our case, the right side is 0. So anyone else have solved this? Got the answer? What is the basis? Anyone? Okay. Sujit is saying only 2 vectors is suffices to. Okay, good. Okay, do all of you do it. Okay, I'm waiting. Please do it so that able to understand it. Let me note it again. Okay, anyone have solved the problem? Okay, like Sujit have solved. That is good thing he have at least. Okay. What about others? Okay, so let's do this problem. Just a second. Let's do this problem. So I have this system means here I want to find the basis of it. Let's take this system of linear equation here. 0 y plus u is equal to 0 and x plus w is equal to 0. So here this tells you what? See, it's already in a simplified way, and this, so no need to write in the matrix form. If you want to write, you can write like this. So this is 1 1 1 0 0 0 1 0 1 0, and then next is 0 not 0. This is 1 and 0 0 0 1, and the right side is 0 here. So this is augmented matrix of the system of linear equation. Okay, so if you want to do in the so it is not in the steps of in the below part is in the upper triangular form. So we can do that here. You can follow the step that you can reduce, you can subtract R1 from R3. Okay, so it will be 1 1 1 0 0. I want to make it 0 here. So this will be 0 1 0 1 0, and this is going to be 0, and this is minus 1, and this is just 1, and this is 0. Okay, so this is here 0 0 part is remaining. Okay, so now next is see, here is the leading one. So below of it I want to make it 0. So you can follow the step that R3 minus R3 plus R1. If you do it here, so this will be 1 1 1 0 0. The right side is at 0. There is no use of it. If you want to write, you can write. Otherwise, there is no use of. You can just are carrying it out. This is 0 1 0 1 0, and then 0 here. Yeah, but the good thing is if you carry out, this will be good. So here it is 0. Now this is 0, and this is minus 1, and this is 2, and 0 0. Now see, slowly it's converting in the upper triangular form. This is minus 1 is there, so let's make it 1. So you can divide R3 by minus 1, or you can multiply R3 by minus 1. So it will be now 1 1 1 0 0, and right side is 0. Okay, and 0 1 0 1 0, and this is 0. This is 0, this is 0, this is 1, this is minus 2 0, and this is. Now see, slowly this part is till here.
Excuse me, sir.
Yes.
Is it R3 plus R2 or R3 plus R1?
Which one? R3.
R3
Oh, sorry.
plus
This is
R2.
R3 plus R2. Sorry. This is
Yeah.
R3 plus R2. Sorry. It was a mistake. So this is R3 plus R2. So this is what we got now. So now see that this is the form here. and slowly below means here it is 1, below of it 0 here. So next row will go here. So this is here, below of it 0. Now next here is 1, there is no below row, so now we can stop here. So this is the final thing. Now we can convert back to the system of linear equation here. So this is your coefficient 1 and this is your right side. So now if you write in the form of system of linear equation, the easy way is that you can write above x, y, z, u and w, and these are tells you the coefficient. So what is here going to be x plus y? The first row tell you the first equation, z and plus 0 time u plus 0 time w is equal to 0. And now next is 0 time x plus 1 time y plus 0 time z plus 1 time u plus 0 time w is equal to 0. Now the third row will give the equation 0 time x plus 0 time y plus 1 time z plus minus 2 time u plus 0 time w is equal to 0. This is what the equation will get. And the more simplified way, you can say x plus y plus z is equal to 0, y plus u is equal to 0, okay, and z minus 2u is equal to 0. This is what you will get. So this tells you now you can send z is equal to that side, right side. So you will get 2u. Z is equal to 2u. And it's tell you a kind of independency also. Or otherwise, if you remember it here, if you see, so where is the leading one? That is your dependent variable. Means here x, this is your leading one. So this is x is there, this is leading one, this is dependent. Y is leading one, z is leading one. But there is now no ahead column, there is no leading one. So u and your w is actually tells you kind of independent variable. So from here you can understand of you are facing difficulty to understand from here. So what you can do, you can see it here. Now z is equal to 2u. You can send right side to u as this side. So this is a kind of feeling that u is a free variable and z is depend on that. And here is also the second equation give you this y is equal to minus u. Again a kind of feeling that okay, u is a kind of free variable and w is not anywhere. Means the w is a totally free variable. Is it? Yeah, I think so. Yeah, because z column is this w column c is everywhere is 0. So means a kind of z is not looking. W is not looking anywhere. Means w is also a free variable. And the
So
from first equation, sorry.
In the first step, I think some mistake is there.
Okay, in the first step here.
Yes, R3 minus R1.
Okay, R3 minus R1 if you do, so this is 0, this is minus 1, minus 1. Oh, this is 0 here, no?
Yes.
What? Oh, this is 0 here. Okay, this is 1 here. Oh, why I
Last column is 1.
This is 1 here, no?
Yes.
Oh, God. Okay. Okay, but yeah, this step is now correct. So no means we will go ahead with this because we want to make it 0 there below of it. So this is now 0 and this is
so in the second step that 2 is not there, it is 1 only.
This will be here 1. So here this is now if you add here, so this is going to be 0, this is minus 1 and this is 1 and this is 1. Okay, fine. All are actually 1 now. Is it 1 minute? R3 plus R2. So this is okay. 0, minus 1, 1 and 1. Okay. This is what it is. Okay. Now if you are dividing R3, so this is 0, 0, 1. Okay. Now 0, 0, 0, 1, 1 and here is 1. Okay. So if you now write this is third equation. So this is correct.
It should be minus 1, isn't it?
Oh yeah, this is 0 here. This is minus 1. This is minus 1. Sorry. So finally what we have, so the third equation only will change here. So this is 0 time x plus 0 time y plus 1 time z. Here is minus 1 time u and 1 time, sorry, minus 1 time w. Okay, sorry. So okay, so this is what we'll get. So finally here is in the last we have w here. So this is z minus u minus w is equal to 0. Okay. And the first one, so let's remove now this all. So again a kind of filling here, you can send this z is equal to u plus w, and here the second equation give y is equal to u, and here it will give, you can substitute y and z in the first equation, so you'll get x plus, you substitute here z is u is equal to minus u is there, no? So this is minus u, so minus u, and z is equal to plus u plus w, so u plus w, so this is going to be u plus w equal to 0, right side one. So this will be cancelled out, so the first equation finally will be converted as a x plus x plus w is equal to 0, and this is x is equal to minus w. So what we got here finally, x is equal to minus w, y is equal to minus u, and z is equal to u plus w. So please again comment me or just stop me to if I am making numerically wrong. Okay. So this is what it is. So this tells you, u and w is a free variable. And to know the free variable also a kind of from here where the leading one, those variables are actually not free variable. Free variable means independent variable, and dependent variable are which don't have the leading one, as here see there is no next row is there and there is no next, so that these variable don't have a kind of leading entries. So these are the we have behind of the leading entry. This is your leading entry, and behind of it these are variables actually coming. Again for the second row, see that this is your leading entry and this is your behind. For u and w, the behind, these two are behind. So this is kind of tells you that okay, for u and w there is no leading entry you are getting. So these variables are kind of free or independent variable, and x, y, z are actually have the leading, so this is a dependent variable. Or in different way from here, so if you are not understanding there, you can understand from here that if you convert in the system of linear equation finally, and once you convert, then and slowly from here you will get that okay, which one is a free variable or independent variable and which one is a dependent variable. Okay, now you can give some value to u, okay, and w to some value c prime. This is this if you don't want to give, there is no issue. The way is that the second way, you can give u is equal to 1 and w is equal to 0. So x will be, you can get x value something, y value something, and z value something, and finally you will get a vector x, y, z, w. In place of that you will substitute the values. Similarly you can substitute w is equal to, sorry, u is equal to 0 and w is equal to 1, and you can find the vector. So by this way, actually, the free variable means independent variable tells you that you will get two vectors independently, and by this way, these two vectors are actually going to be the basis for that, and so the dimension is going to be 2. Otherwise, it is a good practice to writing like this, so that it tells you, if you write like this, this is a good practice. Okay, so that it will giving a more organized way. Okay, so if you assuming u is equal to c and w is equal to c prime, so you will get x is equal to minus c prime, y is equal to minus c, and z is equal to c plus c prime, and u already c is there, and w is already c prime. So by this way, x, y, z, w, and w is nothing but.
Sir, why are you doing elimination process? Because you
Why I
give,
am doing?
yeah, you give the equation x plus y plus z equal to 0, y plus u equal to 0, x plus w equal to 0. Again, this last came this.
Yeah, you are exactly correct. So there is no use of it. There is no u observe, because from here you will get your minus w use y is equal to minus u,
Yes,
correct?
sir.
And then finally you can get x is equal to, sorry, and z is equal to, you can get the value of y and in that form. It's totally a good thing, yeah. So why I am doing this, there is no mean of it even. Yeah, so there is no means from here. So see, if you ask me to solve this, okay, I can directly solve from here. I can solve directly from here. Okay, this is what it is. So it's good to that you understood. Okay, from here directly we can get. So this is the way if your system of linear equation is not organized. Okay, this is already organized. I given the more simplified thing, more very simplified. I have x, y, z simple coefficients. But sometimes your system of linear equation is not simplified. Sometimes a more complex is given there. So in that case, you can, if you are follow these steps, then this is a good way to, this is a good practice to do that. If your system of linear equation is not simplified, if here it is
Yes, sir.
simplified, so you can directly go ahead. There is no mean of doing this. But I'm actually telling this why I'm doing this, so that you will understand this process also. Yesterday we have did, and this is how you can proceed. Otherwise, from here directly you can get right, totally right. If you understood it, this is the good thing there. Okay.
Yeah, okay, sir. Okay.
Yeah, this is good thing here. From here also you can directly get that z is equal to u plus w is going to be y is equal to this, x is equal to minus w. And from here also you can now start assuming at the same step you are reached to, without doing this all. I did for practice your, this is a more simplified, that's why it's look like very easy just arranging the term. But sometimes it may be complex, and then you can follow them. Okay. This is a good catch. So this is what is this assuming to be x, y, z. So you can now substitute. This is minus c prime, c, and z. Z is c plus c prime, u is c, and w is c prime. Now we can write in a separate form. So this is going to be 0.
So y is
Okay.
minus c.
Y is minus c. Yes. So this is I'm writing for first c. So this is c, and this is minus 1, and this is 1 here. Or if you are facing issue, you can first write in the c form. So this is 0 minus c, 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 and 0 plus, let's write for the c prime form, minus c prime, 0, c prime, 0, c prime. So this is why it will be exactly same it is if you add these two. So you can make it out. C 0 minus 1, 1, 1, 0 plus c prime minus 1, 0, 1, 0, 1. So I think Sujit have given the correct answer also. So this is what it is. So these two vectors are actually, this tells kind of, this is actually representation a linear combination. So this is a kind of linear, your solution is a linear combination of these two vectors. Or I mean to say the basis element for this is it's going to be just these two vectors. So exactly you can get this from here also. If you just substitute this way, you will get the same thing, same vectors you will get. And this is your simplified vectors. So the basis of this is this, the subspaces are these two vectors. And so two vectors are there, so you can dimension is 2. So basis is those vectors and dimension is 2. This is how we can follow. So this is a good catch, actually really a good catch, because sometimes the question would be more easier. So don't need this to proceed. Okay? Even in the quiz also, because the quiz is given 1 hour time, so sometimes the equations may be easier to do, but just understand your knowledge. So no need to do this all process. Just go ahead with this one. You are able to catch that. There is no issue. Okay. So this is what the basis dimension span. See, this tells you this representation a kind of a span of these two vectors. and spanning set, membership we have seen. All contents now clear with examples. Okay, so anyone have any doubt? First of all, now, anyone have any other doubt? Any kind of doubt, conceptual or any doubt?
Excuse me, sir. I just want to ask you that whatever you have done with the to do the in this standard form of the equations, is it necessary to do that, or we should go with the given equations? It's not being necessary to do that.
Not necessary, not necessary, exactly not necessary. See, this process are built for the complex when your equations are so complex. So let's simplify that and slowly solve. If you are able to catch exactly, let's convert x to y z and z to x y. Anyhow, just reaches to the vector of final solution. That's all. It is exactly no, not necessary to follow the steps. Okay, it is I am doing for your practice to know that okay you can follow that. Otherwise, there is no, you can, if you are able to do quickly, you can just do that. Anyhow, any method you can follow.
The answer will be not affected, right, sir?
No, the answer is not going to be affected.
Okay, thank you, sir.
Okay.
So
Any other doubt? Any kind of? Yes. Yes.
is it the number of independent variables determines the dimension? No?
That is the answer. Yeah, that is a good catch. That the number of say independent variable is the dimension. Correct.
Okay.
As here. Yeah. So that's why I am doing actually to tell you that okay, this is kind of things happening. This is a free variable or independent variable. These are the dependent variable. These are the really good catch that all of you are getting. Any other conclusion want to conclude so that others will get it, or any other things we have in for that, or any kind of any silly doubts is coming, you can ask even. Any silly steps, simple steps out. That is a good no, because generally it comes in all others' mind also, but no one used to ask even. But if you ask, that is a good thing. Okay, so that's all the content even. There is no more contents also even. I don't have any also to teach because so many concepts I have discussed with example basis. Whatever I want to tell you about the basis, dimension, span, and vector space and vectors, that's enough. And just needed to, if you do yourself practice, the doubt will come in your mind and you can ask. Come to sessions and then ask. That is a good way to learn also. Okay, so anyone have any doubt? No doubt. So I want to stop now because from my side nothing is now remain. Whatever I want to tell you, I told. Don't have doubt. We can stop now, and okay, we can stop this. No doubt. Fine. Okay. Okay. Thanks
So
everyone for joining. Yes, Jadev, do you have anything? Sorry.
um,
Yeah. Yes.
regarding yesterday's class, actually, it's
Hmm.
a small doubt. Actually,
Hmm.
a vector,
Yes. Go ahead.
two vectors are there, and if here it was told that a vector is drawn from the origin,
A vector is
drawn
okay.
in
Drawn
a
from origin.
partition
Hmm.
from the origin. Suppose two
Hmm.
vectors are there, and we are subtracting one vector a minus b.
Hmm.
So that vector is not from the origin, isn't it?
Actually, what if okay? So that is a good question. So yeah, I got this question from some other class also. That even subtract or adding. Okay, so the thing is that let's say I have this two vector. Okay, I'm just doing in R2. So I have this one and 1 2. Adding or subtracting is the same thing. So let's do that operation. Let's say 3 and 4 is there. These two vectors are there. So when I'm doing, I will get a vector which is of 4 and this is 6. So let's do on this coordinate system. So 1 is there and 2 is here. So somewhere the vector 1 2 is here. So this is 1 2 is here. So 1 2, let's write. vertically, and 3 4 is there, so this is somewhere 3 3 and so let's do it. Let's say here it is 3. So this vector is going to be this one. Okay. Now when I'm adding this, so the way to add the vectors is the parallelogram law is called. Okay, but I don't want to introduce here. Okay, we are very rough linear algebra doing, so let's forget about the law. So I'm adding. So adding is going to be this. So if you add this, you are getting 4 6. So somewhere 4 6 is going to be here. Say here, or maybe here 4 6. It's going to be here 4 6. So this is the vector. If you are adding this, so you will get this too. So vector, if you add, so this could be a kind of this one. If you add these two, it is going to be this one. So this is how the parallelogram law. But the reason is that if you add, then whatever the vector you will get, the vector representation is like this. So actually the way is, if you see the why I'm saying many times parallelogram law is that, let's say I have this vector, okay, and the another vector is this vector, okay. When I am then, let's say this is u and this is v. When I'm adding, so adding two vectors is like this only. So if you add u and v, so adding u and v is going to be, so actually what is happening once you add here, so actually this, if you add this v to here u, so this adding is actually done like this generally. In the same way, just shift that. Okay, so whatever this vector you will get, this is your u plus v vector. Okay, but if you want to, this is your vector u plus v. This is your added vector. But I want to tell the vector it is, so vector is going to be this one, u plus v vector. This is what it is. So if you add these two vector, this vector and this vector, you are getting this vector. Okay, so finally the vector representation is just draw the line in the top. This is your vector. It's look like this. So this is called the parallelogram law. Okay, this adding the vector is this is called parallelogram law. But yeah, this is the meaning of it. Are you able to catch it? I don't know. I didn't tell you in a more broader way, even not a good way.
Yes, I understood that, sir, but
this is
I'm
what
not
it
able to
is.
relate it with the real physical world. Suppose in the here, what we are explaining is that we can shift to u. So in mathematics, we can shift to the origin.
So actually, we are not shifting it. It is actually understood that, okay, not here. It is not actually meaning of shifting it. Okay, your vector is here only, but adding
Okay.
is that it's look like this. This is virtually it is. Okay, this is a kind of virtual. Your vector is actually here only. Your vector is here only, but when you are adding them, it's actually doing like this, and then finally you are getting vector here. So this is your vector, but your vector is here only.
So suppose two forces are acting on a body. That suppose two forces are acting on two separate places.
Correct. Yes.
Then how it can be related to this vector? That is.
So let's do that in the visual line form. So let's say I am this one. This is a ball. It is, or let's say iron ball. Okay, a big iron ball. So one force is acting here, and one force is acting here. Okay. So let's do on this. Let's do on the. So one force is acting here means actually, so there is a shift is happening here, okay, but actually once your force F1 is there and F2 is there, okay, so the final force is will be done on the center of gravity, okay, generally it is called. So this is the final thing is there, this your force is in the direction, and this is your F1 and the force F2 is in this direction, but it's actually happening on the center of gravity. So, and this is how it will start rotating. Maybe I don't know, it is maybe some shift and rotate, but this is how happening. So the final force is that this F1 plus F2. final force is going to be F1 plus F2, just adding them.
Yes. But that direction is
Here the acting place is also differ, but the final they actually it is happening on the center of gravity, and this is what it's happening. And the center of gravity, you can assume that this is a kind of origin. You can think that okay, it's happening on. You can think like this. Actually, many things, it is in some reference we are studying this all. So it's look like you are doing a shift is there. There is a vector is acting there, and there is a shift is there. But it's actually at a particular point, all those things are happening. And generally, the vector is we have like this. Always visualization is a very tough thing, but the algebra that's why the algebra slowly developed that, and the algebra is that doing these two vectors or adding the final force is going to be just adding these two force.
but here when we add, we will get a force in the almost in the x direction.
So if you add these two force, so I don't know what is the force is that if you add this, so it
Suppose
may
if
be
both
a
are equal.
subtraction, no?
Suppose both the forces are equal.
Hmm.
In that case,
Then it
it
is a
will come in
start.
the middle.
In this case, it will start rotating, right? I think. Yeah, it
Yes,
will
it will
start.
rotate.
Hmm.
But when we add these two forces, it is giving a resultant
Zero.
force.
Sorry.
No,
Yeah, it will give the
it is
resultant force.
that is in the almost in the x direction or somewhere in around 45 degrees or something.
Yeah, it is the exact it's the same equal force with the opposite direction even. So this is going to be this one.
Okay, if it is opposite direction, okay, then
So
equivalent
see,
force
if you
is
want to,
zero.
if it is exactly not opposite direction, then surely this ball will some move and then rotate. Means move and rotate
Okay,
both will happen. But if
right.
maybe if it is on some fix is there and on some stick it is, and that is so it just start rotating. It will not
Oh,
shift somewhere. So this is more, this is a physics thing. I don't know, so many things are involved in that, but this is how it is generally. Yeah, but vector is the
oh,
same meaning here as in the maths, and there in the this here is the same meaning is there. Vectors, that is what called the vector it is. But we are studying here in more algebraic or in the this form, in this representation form, a matrix form. There in physics is generally I don't know how it is.
okay, sir.
Yes, Sonali wants to say something.
Yes, could you please go to that slide?
Okay.
This u plus v is the longer one, sir, right, sir? This is the resulting one,
Yes.
not that shorter one which is vertically.
This longer is the resultant. Okay.
It's u plus v, right, sir?
This is u plus v, correct.
No, no, no. I'm talking about the next graph.
This one, okay.
Yeah.
Hmm.
This longer one is the resultant, which is equals to u plus v,
U plus v, right?
and then that shorter one is v that you're
Yeah.
shifting it.
This one
Okay.
is, yeah. This is v.
Okay.
This is your v and this is u. Yes. So actually, there is not generally shift. Okay, so always saying to be the shift means adding means yeah, generally at the top. So see, these operations are defined like this so that it's look like we are shifting and adding. So okay, generally if you do this operation is defined like you are adding the coordinate wise, just a coordinate side addition. It is 3 plus 4, 3 plus 1, 4, and 2 plus 4, it is 6. So on the tip, here it is 1, 2, here is 1, 2, and this vector is 3, 4, 3, 4. So what's happening in 1, 2, if you add these two on top, just adding here 3 and here is 4. So that's how it is going, and finally. So these are actually, say, some laws, actually some forces. How this parallelogram law, we have to deep and dive to understand parallelogram law. But this is your parallelogram law. This is called parallelogram law. Go more in deep how it's generated, to see it even. Okay, but this is how it's happening. So we are adding two vectors means take one vector and think about I have shifted to here and it's placed at the top, and then finally you will get the resultant. This is what the parallelogram law, and this is what the vector addition. Okay. Okay, good to we discuss this at least. I don't know, some result may you get, may understood that, or maybe you will see some. You can start exploring parallelogram law. You can go in the, you can do the Google search, and this is a good thing. Okay. Any other doubt? Sujit?
Nothing, sir.
No? Okay. Thanks everyone. Thanks for joining. Okay. This is done week 3. We'll meet on for week 4. I hope I have tried to convince you. Whatever in my side, I will try to, whatever I have, I try to tell you that, okay, these things are there. Okay. Try to do practice and grade it. Submit your graded assignments. Okay. Thanks everyone. Thanks for joining.
Thank you.
Good night.
Goodbye.
Thank you, sir.